Assalamu alaikum everyone. This is Dr. Zahraء Salim, faculty of the Department of Chemistry, Mustansiriya University, and the constructor of research methodology course and writing your thesis and research paper course. This is the first lecture of the second course, which will deal with writing your thesis and your research paper. But before starting the second course, I would like to refresh you about some information that you've already studied in your first course. I'll give you a brief summary about your first course in order to let you know where you are standing now and how to connect the information that you've got from your first course with that you will get in the second course. So let's start. If you remember this scheme, which I told you this is the structure of a typical research project, and your project should follow this scheme. This scheme breaks down your project into 4 phases: phase 1, phase 2, 3, and 4. So fortunately, we studied phase 1, 2, and phase 3 in the first course. We were really lucky. And now we are going to study phase 4 in the second course. For these 3 phases, I will briefly remind you, when you will start your project, you need to first communicate with your supervisor about the good and novel topic for your research work. So you need first to do a literature survey, a quick literature review, and have a look at the work of others in the area, in the field. What have they got? What were their results and their conclusions? What is the missing part in their project that really need to be studied? So here you need to find a good problem, and to find that you need to ask yourself critically, what are you going to do, and is it worthy doing? Why you are doing this project? Um, what is the interesting part in your project? And how you will do that, what kind of methods, what kind of designs that you will choose. And your timetable is really important. You need to set up a timetable for each phase from the beginning. This will facilitate your work and shorten the time of your research project. Once you've recognized your main problem, you need to put a suggested solution or make a hypothesis, as we studied before, and we studied this extensively, so I'm not going to repeat that. I just want to remind you. So your hypothesis should be logical, should be realistic, and you need to put a null hypothesis, and by the end you will either confirm your hypothesis or your null hypothesis. After that, you need to go through one or two or maybe all of these designs. You need to pick up one of these designs in order to perform your experiment and to confirm your hypothesis. And these are the standard designs that everyone will use in order to do his research. And we studied these designs extensively as well in the first course. Then you can, at this time, you can put an expected result, and you can expect the conclusion from your results, which will lead you to put an expected statement or argument. according to the main problem, the hypothesis that you put, the designs that you picked up, and the conclusion that you will end up. So to put your argument, you need to choose one of these terms, and we also studied this extensively. Um, by getting your argument or your thesis statement, you will end the first phase here. And so the first phase depends on your theoretical background about your subject, depends on your literature survey, your communication with your supervisors about the problem, the possible solutions, the designs that you will use. So all these steps should be done with your supervisor. Then here you need to enter into the second phase where you will write your proposal, and these are the points or steps that we illustrated before, and this will definitely help you to write your proposal. This will take around 2 to 3 weeks writing your proposal, and then you will introduce it in front of a scientific committee in our department to discuss your project, to discuss your hypothesis, your designs, the main problem, discuss everything in your proposal, and then they will either approve your proposal or suggest some other things, make some modification in order to get a good project. But by the end, they will approve it definitely. So once your project has been approved, you will end the second phase and you will enter into the third phase. The third phase is your academic year where you will do your research work. But before I start your project, I will really recommend to think carefully about the research ethics. You will need all these ethics throughout your study. Build these ethics in your mind. All of these are very important. You need to be honest when you are doing your research, when you are collecting your data, when you are showing your results. Honest, integrity are really important. You need to be a respected person and respectful. So, respect is very important everywhere, and it is important in your research as well. Respect your lab mate, your classmate, your supervisors. Also, you need to follow the rules that issued by the department or by the institution that you are communicate with. You need to be very organized. You need to be a regulated researcher. And we will have a workshop about that. I need to show you how to be organized and regulated researcher. You need to be confidential with the data that you are collecting, with your results. For example, if you are collecting data from patients, so you need to be confidential with the information that you've got. Don't share this information with your colleagues or your family because this patient trusts you and passed you his private information, so confidentiality is really important. You need to have some skills throughout your study work. You need to follow the values that set it up by the lab or the technicians, your department. All of these are really important to build in your mind throughout your study work. I also recommend to familiar yourself with the techniques that you will need. I mean, I always recommend students to spend the first 3 months for PhD and um, the first month for master students to do some training with techniques that you will use. For example, if you will need CHN or HNMR or like sandwich ELISA, direct, indirect ELISA, whatever technique that you will need, go to the area that the technique is located and have a training and do a mock run, like familiar yourself with the run, with the result, and have a look at the result. Communicate with the technician or with your supervisor about the data that you will collect and see if you can interrupt these data. How can you explain this? Familiar yourself with the technique and with the run, with the sample. You also need to set up a table about all the techniques that you will need, the material that you will use, what kind of chemicals that you are going to have, and like write down where are these and how you can collect all of these, how you can collect your chemicals and so on, because this will really make your steps very easy and short. Also, you need to write down what kind of skills that you need throughout your study to make a quick progress, because definitely postgraduate students need some skills for their study, either scientific skills or self improvement, which are important to facilitate the work. Um, these skills should you have to have these skills at your first year, because at first year like the work is up and down. So spend the first year to have some skills, to have some training, although trainings are really important along 4 years. Also, I recommend each postgraduate student to communicate with his supervisor about the suitable conference in his field, because attending conferences is really important to strengthen your knowledge, to have networking with others, and networking is really important to expand your thoughts and ideas and have support from other researchers from other institutions. So attend one conference per year is really good. Um, so now you are ready to start your uh, third phase by doing some deep research to know what kind of methods and analysis that you will need. Is your project quantitative or qualitative? You need to carry out your research, so you need to collect your data and analyze your data. Um, so if you remember, we classified the research either qualitatively or quantitatively, and we said that qualitative research um, we said that if you are going to do a qualitative research, then there are some methods to collect your data, either by asking questions through questionnaire form, personally by post or through internet, or by doing interviews, which are either structured, unstructured, or semi-structured interviews. We studied that extensively at first course. Also, observations are good for qualitative data collection, or you can collect your data from an existing source. And once you've collected your data, you need to analyze your data. So there are some ways to analyze your qualitative data, either by set it in a table in Excel to show the frequency and percentage, no more that, or drawing a histogram about the frequency or the percentage of your samples, or pie chart, or drawing a scheme of your steps and showing the result of each step qualitatively. Or you can draw your question by as a reaction, or draw a mechanism for this reaction, or you can show your result as image, especially if you have done scanning electron microscopy or transmission electron microscopy. um, these are different kinds of image. This is the confocal image of fibroblast in humans, so you can show very nice images which are really good for your thesis or for your paper. You can also describe the reactions by showing the color of the resulted solutions, describe it in a table. You can show a movie, but this definitely not in your thesis, but in your manuscript. You can submit this movie with your manuscript to the suitable journal, and this is really good if you would like to publish your work. So all of these are ways how to analyze your qualitative data. If your research was quantitative, then you need to collect your data by one of these methods and then analyze your data either by test your hypothesis. This should be done statistically by one of software like SPSS or Prism software. This will do the this will test the hypothesis automatically and giving you the p-value which present the significance of your results. So you always need to show the significance of your results, because this will really confirm your results. You can do manual measurement, like measure the concentration, the velocity, volume, current, or whatever, and showing that in a table, like show the numbers, the mean, the standard deviation in a table. Or you can show your result by graphs and analyze these graphs by showing the standard deviation of each run, and so on. Sometimes you can collect data from a machine, like from the instrument, like for example FTIR, NMR, CHN, all give you ready to collect data. You only need to show these data as a spectra or in a table. So these all are ready to collect data. This is data of liquid chromatography mass spec. As you can see here, everything is ready to collect. You just need to show it in a nice way. You also can analyze your quantitative data by showing a relationship between variables. For example, this is a standard value, and this is the first variable, this is the second variable, and this figure showing how the first variable was significantly lower than the standard value, while the second variable was significantly higher than the standard value. So this shows the relationship between these variables, and this relationship could be statically studied by showing the correlation coefficient, either a positive correlation, negative correlation, or no correlation. You can also show your data and analyze it by doing a comparison between variables. Compare between X, Y, Z variables and determine the percentage, the Mallory ratio, the differences or similarities between variables. Or you can use your data to make a forecast. For example, this is the data, the XY data of obtained by crystal by data of X-ray fiber diffraction or X-ray crystal diffraction. You can get the XYZ data, and then you can use this data, analyze it, and construct the concept about the model of the molecule. You also can use your experimental data to suggest mechanism or theory about your reaction. So um, all of these could be done by your experimental quantitative data. So these were our topics in the first course, and I hope I gave you a good summary about that. What we will study in this course is all about writing thesis and research paper. So the first lecture will be how to search the databases to get good information for your writing, to have good references to support your introduction, your discussion, conclusion, and so on. The second lecture will be about the most common citation tools, and I will show you the easier one, and will make workshop for you to be familiar with that and to use it perfectly. And then the third lecture about writing your thesis in a second language. Fourth lecture will be what are the good strategies to avoid plagiarism. And then we will study this thesis structure by 2 lectures. We will have a workshop for that, and we will study how to write your research paper professionally, and then how to publish your work, how to respond to the reviewers. So this is the syllabus of our course. Go back to this scheme. So you can see that you need to search the literature review. You need to have a literature survey at many points of your research work, here, and before starting to write your thesis. We studied in first course, there are some sources to get information. For example, the libraries, your colleagues or researchers, your supervisor, maybe your supervisor have some publications which are really useful for your writing, so have a look at that. Also, the internet is very good and useful to get the correct and professional information. So you either use search engines that we already studied, that you either search your information by using one of these 2, 3, or maybe some of these to get information. For example, I expect that all of you use Google Scholar. So if we go here, you need to advance your search because you're already doing advanced research. So for example, if we give it this keyword with coronavirus in Iraq, so I'd like to see this keyword everywhere, like from 2018 to 2020, what works are there. give it a search and see what can we get. So here, so I can get good references here since 2020, 2019, 2016, and I can download the PDF here, which is really good. Okay, so these guys are from University of Ambar. They did publish this work to 2019 about detection and some DNA RNA virus rates and patients with acute respiratory tract infection. Yeah, anyway, you also can use academic search to have good information and good references if we use the same keyword. See what we can get. Detection of bovine coronavirus in some governors of Iraq. Yeah, you can have a look. Actually, it gives you the field of this topic. All these fields studied this topic, and there is a journal, patents about coronavirus in Iraq, and these are the authors that done this work, the top journal that published this work, which is really good and useful. You can also use Google Book to find some electronic books, and you always so we go back. Yeah, so I will use the same keyword because this is very hot topic now. Let's see what we can get. So we have coronavirus replication and reverse genetics, which has been published 2006. Oh, this is in 2020, Corona COVID-19. Wow. So yeah, so this is really good, and you can refine your search here, specify if you need books, magazine, newspaper, and you can have it at any time. You can do refining here for your research. Sometimes you can download the book. I'm not sure if you can download this or no, but sometimes these are really free to download. Yeah, you need to know this is not a free. So you need to have a look at that. Sometimes they provided a PDF of electronic books. So all of these are really useful. These are good search engines to have your references. In addition to that, you need to go across the databases and have an organized collection of information. So the databases is just an organized collection of information, either related to a particular subject or kind of disciplines. So it contains different databases contain different types of information. So the most common databases here are Web of Science, Scopus, Science Direct, Google Scholar, Springer Link, PubMed, GeoBase, IEEE, and Psychoinformation databases. So we will go through each one briefly, and I will show you how to use each databases to get your references. Um, if we start with Web of Science, actually with Web of Science is general. That means it multi-disciplinary databases. It has very high impact research. It's a unique search method, and you can search by topic, author, date, and the title of the subject. The Web of Science covers many fields like science, social science, arts, humanities, conference proceedings, and these are some statistics about the coverage of Web of Science. However, unfortunately, we cannot access Web of Science yet because we don't have account uh, as a university. We still don't have account to access Web of Science, but we still can use some of its service like uh, mm, the master journal lists, which enable the researcher to do a quick research about a specific journal if it is included in the Web of Science or not. So, for example, um, say one of the journals like um, Iraqi Journal of Science. I'm not expecting this to be included with Web of yeah, Iraqi Journal of Agriculture Sciences. It's in Web of Science. So it gives you some details about this journal to view the profile of the journal. If I will log in here, then I can um, okay. I can connect with the list, the master list of journals by logging through my ORCID account. Oh my God. Yeah, so it will give me all required information about this journal. Um, which I may need it to know the suitable journal for my publication. Um, so Web of Science is not available for us for now. I just wanted to show you this database. The other common database is Scopus, which we all know about it. It's a multidisciplinary database. It has a large database for abstract and citation quality web sources. It also has smart tools to track journals, to track papers. Um, you can find who cited you. You can find your citation, your H index. Um, you can check out the work and citation of other researchers. You can analyze the citation of particular journal, and you can search by author name, journal name. It's really useful database for researchers. It covers um, journals, book series, conference papers, um, and it covers 21 million per pre 1996 records. So it's really good database to go over and have a look about the most useful information that you need throughout your research. Um, if we click that here, if we click that button, um, oh, no internet connection. So many of us need Scopus to search about the suitable journal that he needs to publish his work, or even to collect data. So I recommend any postgraduate students to collect high quality papers. So not to collect papers everywhere, no, just to choose the suitable journal, the suitable database to collect your references, because good references in your thesis and in your research will definitely show that you've done good work. Yeah. So this is the main page of Scopus. Um, Here in sources, you can search about the journal, Iraqi Geological Journal, Pharmaceutical Science. I guess this is good journal, and see what is the cite score or the journal, the citation. This is still don't have cite score. And you can press this button to show the coverage of Scopus for this journal. So this journal uh, is covered by Scopus from 2013 to 2018. And it shows you the cite score of this journal, how many citations. This is the cite score in 2019, and it also shows you the cite score rank of the journal. So yeah, so you can use this option to search about the journal. You can save to a source list. You can go to the journal homepage here and see what are the instructions for researchers to submit their work. So yeah, so this is the homepage of the journal, and you can search about it in your free time. The Scopus also allows you to know the citation, your citation or citation of your friends. For example, let us see what is the citation of this circle. So this guys has 140 documents in Scopus, and her H index is around 54, and this is her citation from 95 until 2020. Also, I guess you can see who cited her. It shows you her publications and her field of study, and you can follow the H index of any researcher here. Yeah. The other important database is Science Direct, which is really useful. I always use Science Direct to collect my PDFs, my references. This is the Science Direct has an open and non-open access papers, and you can search by date, title, author information. You can read the abstract. You can have a full resolution image from the article. It's really useful. It covers many fields in sciences, health, medical research, earth, plant, and planetary science. It is a multidisciplinary database. So we can have a look here. Press this button. This is the main page. For example, if we give it this keyword virus, we need to have advanced search. Virus. For example, 2019. I don't have any author name. Yeah, coronavirus. Let us see in Iraq. Let's see what it will get. Oh my god. So it shows you that there are 11 publications in 2018 in this field, and there are 4 reviews, 4 research articles, 1 encyclopedia, and it also shows you the publication title. You can have a look here. This is open access, so you can download the PDF, download this article. You can download the full issue as well. So this is really useful. So Science Direct allows researcher to add this reference to Mendeley directly. If you press this button, this will be added directly to your library. So you don't need to download it in your desktop or import it and export it and this stuff. You only need to click this button and you will find this reference in your library right away. So this is really good. Or you can export it here. By the way, you can export it here. If you have export the citation, like the style of citation, if you have one of these citation tools, you can share this by email with your friends by this stuff, or you can download it on whatever. So this is really good database. I'm always using Science Direct for my writing, which gives you high quality research, not fake research, not fake journals. Yeah. The other database is Springer Link, and it's a full text database for journals, books, protocols, references, and sometimes it has free access research. You can access the tables and abstracts even if the paper is not free access. Um, you can use Firefox, Internet Explorer, or Google Chrome to go across Springer Link. It covers peer-reviewed journals and books, so it's really good for publications. It's really good to have um, high quality publications and high quality references. If we click this button to see what we can get. Yeah, so here, so this is the main page of Springer Link. Um, you need to have advanced search here. So if we see coronavirus in Iraq, the same keyword. Let's see what we will have. Oh yeah, so it shows you that there are 6 chapters, 5 articles, um, 2 references, 1 conferences about corona in Iraq. Um, all these studied corona, all these fields. Um, yeah, and sometimes you can have the PDF file of this publication, or you can have a look at the abstracts. Actually, this is the full text of the paper, and you can always download it, which is really good. The other databases is PubMed, that what Auras um, told us before. She showed how she did use PubMed to collect her PDF or references for her research work. And PubMed has developed by the National Library of Medicine. It provides free access to Medline databases for more than 11 million bibliographic citations. Um, it's very old Medline, and it covers many fields of medicine, nursing, dentistry, and pharmacy, healthcare issues, biotechnology, molecular biology databases. And this data, all these databases contain DNA and protein sequences, three-dimensional protein structure data, um, and assemblies of complete genome in an integrated system. So this PubMed is really useful, and Oras showed us how to use it. I'm not gonna to reuse it again. We have PubChem. I think we discussed this previously, but I would like to show you again how to use it, because this is really important for chemists. So if you'd like to search about compound or specific substance or bioassay, for example, if we say, if we put this keyword again and see what can we get as a bioassay for this virus. So nothing here. Biovirus in Iraq. Coronavirus. We have some issues from other parts of the world. So we have 240 active compound in this regard. You can have a look at these carefully. Can also to research about use the traits. So you have 72 bioassays for this subject. There are 21 patients here. 21 patents. Yeah, you can have a look at all of these, which are really useful for your introduction or your discussion part. The other databases is GeoBase, and GeoBase is specifically for geosciences, which is a multidisciplinary database for bibliographic information and abstracts for geosciences. It covers all these fields of geoscience, which is not your interest. Also, we have another database. It's issued by the Institute of Electronical and Electronics Engineers, which cover all fields of electronics, which I guess is not your interest as well. In addition to the final database, which is issued by the American Physiological Association and contains more than 3 million citation summaries of articles, book chapters, reports, and it's easy to search. And it covers all fields of physiology, nursing, psychology, education, and so on. So you can use all this data by the same idea of searching, like put your keyword, have advanced search, and see what you can get from these databases. These are really useful for your research. So by the end of this lecture, I want to ask you, will you start your writing after finishing the lab work? I will give you a tip here. I recommend to start writing while you are working at very time of your first year. Be familiar yourself with writing. Do a regular writing is really important to improve your writing skill. So I always recommend students to do like 400 words per week. Like specify 1 to 2 hours per week to do regular writing. This will force you to read, because when you write, you need to read. So reading is really good to improve your English language and to improve your writing as well, because you will follow the author way, how he did write his manuscript. You will follow him. You will see how he structured his manuscript, his articles. So do writing at your first year and follow your writing, like when you are doing a piece of writing, pass this piece to your colleagues, to your one of your family, and have a feedback about this writing. This will really help you to improve your writing skill. If you didn't start writing from the beginning and postpone writing at the end of your lab work, you will really shock about writing, because writing is not easy. So it's not good idea to start writing at your fourth year because you will find it very difficult. So please familiar yourself with writing by doing a regular writing each year. Thank you for listening. I hope this lecture was useful for you, and I'm ready to communicate with you. If you find yourself you need to discuss something, you need to ask something, please drop me a message and I will be available shortly. Thanks very much.